In this video, we're going to be determining the gradient of the curve at a point. Remember, the gradients of a curve at a point are different at different points. So for example, when x equals to -1, when x equals to 0, when equals to 2, when x equals to 3, your gradients are going to be different, right? Because we are curving. So at each curvature, the gradient is very different. It's not like a straight line where the gradient is constant, right? Perfect. So that given, we're going to be looking at the graph of g of x, and then we're going to determine the gradient of this graph when x equals to -1. So in this case, ladies and gents, they didn't specify which method we should use. There are two methods in total. It's either you're going to use the rules of differentiation or you're going to use first principles. But for the purpose of learning, I'm going to show you both methods. Going to show you both methods. The rule is the shorter method, and then first principle is the long method. But in the exam, they'll always state if they want you to use the first principle. Otherwise, you always have to opt for the short method. You only use first principles if the question says use first principles. Okay, perfect. So without wasting time, let's get to it. So we have g of x, right, equals to 3x squared. The gradient basically is the derivative, derivative of the curve, right? So the derivative is given by this formula, g prime x. This just means the gradient of the function g at any x value is given by this. So the rule is this. You take the exponent, you multiply by the variable, by the coefficient, which is 3. So you're going to say 2 times 3, which gives you 6. Right, and then you still write your letter. And then you take the exponent, you minus 1. So 2 minus 1 is 1. So you are just left with 6x after deriving. But we're looking for the gradient when the x value is -1, right? So we're going to substitute -1 into the gradient formula, which is -6, right? So we know that, okay, if we do first principles, our answer must be -6. First principle is just the same thing as this, but a longer way of doing it, okay? Perfect. So now let's get straight to first principles. So I'm going to just erase this so that we have space. Okay. So we're going to use first principles now. Okay. So the derivative of g of x is the same as the limit, right, as h approaches 0 of g of x plus h minus g of x all over h. This is the formula for first principles. You need to know it off by heart. Okay, perfect. But we're looking for x equals to -1. So I'm going to replace all the x's, this one, and that one, and that one with -1. So I'm looking for g prime, -1. Okay, let me write this nicely. Okay. So where there was x, I put -1 equals to limit as h approaches 0. Here, basically, I'm going to have g -1 plus h minus g. Where there was x, I put -1 all over h, right? Perfect. So now, ladies and gents, before we proceed, we need to get these values. Now we need to get g at -1 plus h and g at -1. Okay, sharp. So I'll show you how to do this. It's very easy. So we're going to start with this guy. Before you substitute this, on your graph, just rewrite everything, but where there's x, leave spaces. So I see there's g, where there's x, I leave a space. And then there's equal sign, there's 3, where there's x, I leave a space. then I have squared. I know that the x is now minus 1 plus h. So even here it's minus 1 plus h. The method is simple. You just rewrite your function, but where there's x, you leave spaces, and then you are going to put in this guy. Ne? Yeah. So we're looking for g at, which will be 3 minus 1 plus h minus 1 plus h. Ne? And then I'm going to leave the 3 here and deal with the brackets. Minus 1 times minus 1 is positive 1. This times that is minus h. H times negative 1 is negative h. H times h is h squared, right? Which gives you 3. These are like terms, so the 1 doesn't have a like term. This 2 will give you minus 2h plus h squared, right? Then we can multiply the 3 in. You're going to have 3 minus 6h plus h squared. And then g at negative 1 plus h, it's equivalent to 3 minus 6h plus h squared. I'm sure it makes sense, ladies and gents. Now I need to get this one. I still do the same. Ne? I write g, where there's x, I leave a space, and then I see there's a 3, where there's x, I put space, and then the squared. I'm looking for g at negative 1, so I put negative 1 there, negative 1. This gives me 3. So g at negative 1 equals to 3. Okay. So now we can come back here and substitute. Let me just substitute from here. So we have limit as h approaches 0. Remember, this guy is there, and then we found that is equivalent to this, right? So where I see that, I can easily put this, which is 3 minus 6h plus h squared all over. Oh, sorry. You have minus, this negative is there, right? And then g at negative 1. So this guy here is equivalent to 3. So I'm going to put 3 there, and then all over that h, right? Then we have limit as h approaches 0. You can see that this 3 will cancel with that 1, right? So you're left with minus 6h plus h squared over h, right? And then, ladies and gents, in this case, we still cannot substitute as per discussions in our lesson 6.1.1 about limits. I said if when you substitute this, you get 0 here, you cannot substitute here, right? Perfect. But the exciting thing is I can see that there's a common factor of h there. Ne? So I can take it out. So I'll be left with minus 6 plus h all over h, right? Then this h will cancel with that one. Then I'm left with basically minus 6. I can substitute 0 there because the h has cancelled, you see? So I'm left with that. Now the bottom is no longer there, so I don't worry about substituting, right? Remember, the main rule for limits is you cannot substitute if you are getting 0 at the bottom because you are going to have undefined. And we can see that the gradient is negative 6 when we use first principles as well. So when I use the rule, I got negative 6. And when I'm using first principle, I'm still getting negative 6. So I know I'm fine, right? Perfect. We're going to move to the next question. But ladies and gents, I advise you to pause the video and attempt it on your own and resume to check your solution for both second and third example. Ne? We're going to do 2 more examples basically. Okay. Okay, now that you have attempted, let's do it. So I'm going to just choose a different color. Feel like a different color. Let me take this green. Perfect. So we're firstly going to start by using the rule. Ne? Remember the rule is you take the exponent, you multiply by the coefficient. So it's going to be 4x. And then you minus 1 there. So it's going to be 4x to the power 1, right? And then you're going to have minus 5. why do we get minus 5 here? Ne? So let me show you. You basically have minus 5 x to the power 1. So you take the exponent, you times that, you get minus 5. And then you take the exponent to minus 1, you get x to the power 0, which gives you minus 5, you see? So you should know that the derivative of x is basically 1. Ne? So basically the derivative of this guy is 1. So you're gonna get 1 times negative 5, which is negative 5. Sure. So now let's check this. We're looking for the gradient when x is what? 2. So we're going to put 2 there. And then we have 4. You have 2. You have minus 5. So you're going to have 8 minus 5, which is 3. Which means when we do first principles, our answer must be 3. If we don't get 3, it means we made a mistake somewhere, right? Sharp. So now let's get straight to the first principle. Let me just erase quickly. Sharp. So the first principle, remember you firstly start by writing the formula. F prime of x, or the derivative of f of x, is the same as the limit as h approaches 0, f of x plus h minus f of x all over h, right? Remember I said this is the formula for first principles. Ne? So we're looking at f prime at 2. We're replacing all x values with 2 now. So where there was x, I'll put 2. Limit as h approaches 0 of f at 2 plus h minus f at 2 all over h, right? Now I need limit as h approaches 0. Remember, I need to simplify this first before I substitute. So I always do it on the side. So I'm looking for f at 2. So I'm going to leave a bracket everywhere where I see. I'm just rewriting this guy basically. Ne? So it's 2, but where there's x, you just leave a bracket. Ne? Then minus 5, and then you leave a bracket there. So let's find f at 2. Ne? F at 2, I'm finding this guy. So everywhere I put 2 there. So f at 2 will be the same as 4. Let's see what is f at 2 actually. It's 2 squared minus 5 times 2. So f at 2 gives us negative 2. Ne? Sure. Now we need to find, so we're going to do the same thing. I'm going to rewrite the function again. So it's f, then where there's x, I leave a bracket, equals to 2. There's x, I leave a bracket, squared minus 5, leave a bracket, right? I need 2 plus h now. So where there's x, I put 2 plus h, put 2 plus h, and put 2 plus h. And then let's see what does this gives us. So we have 2 plus h, 2 plus h, minus 5, minus 10. It's minus 10. So let's write it nicely here. Sorry about that. So it's minus 10 minus 5h, right? And then here we're going to have 2. Now let's multiply this. 2 times 2 is 4, plus 2h, plus 2h, plus h squared, minus 10 minus 5h, right? This gives us, I'm just going to, you can see that these 2 here are going to give you 4h, right, when you add like terms. So basically inside the bracket, you have 4 plus 4h plus h squared. Ne? Now you can multiply everything by 2. So we're going to have 8 plus this times that gives us 8h plus h squared minus 10 minus 5h, right? Then we can see that 8 minus 10 gives you negative 2. Then 8h minus 5h gives you plus 3h plus h squared, right? Perfect. Which means where I see f at 2 plus h, I can replace with that guy, né? And then where I see f at 2, I can replace with that. Sharp. So here is the same as seeing that, né? So this guy, I'm going to replace him with that guy. So it's minus 2 plus 3h plus h squared. And then there's a minus here. Then f at 2, we replace it with negative 2. So we put negative 2 where f at 2 was. Then let's see what does this give us. Ne? Let's see what does this give us. Okay, so we need to proceed to say, okay, the limit as h approaches 0. We can see that, okay, this is negative 2. Here we're going to have a positive 2 because negative and negative gives you a positive. So the 2's cancels, you see. So you have 3h plus h squared over h. As things stand, we still cannot substitute because we're going to get a 0 denominator, which is undefined or no solution. So we need to find a way to get rid of h. And on this step, ladies and gents, I'm sure you are noticing that there's always a common factor here. Né? So you're going to have limit as h approaches 0. I take h out, so I have 3 plus h all over h, right? Then this h will cancel with that. Then now there's no longer the bottom, you can substitute 0. So it's 3 plus 0. Remember, when you substitute, you no longer write the limit. Ne? Then the answer is 3. And this is the very same answer as we got when we used the rule. Then we know we are fine, right? Perfect. So we're going to do the third example now. I advise you to still pause and attempt it, and then resume the video to see if you understood. Ne? Perfect. So we have k of x equals to minus x cubed plus 2x plus 1. Let's derive this. Ne? So the derivative or the gradient of that function is given by, remember I said there's an invisible one here. So you take the exponent, you multiply with that, you get negative 3. And then you take the 3, you minus 1, you get 2, right? Here there's 1, so it's 2 times 1, which gives you 2, right? Here you're going to have x to the power 0, which disappears. Ne? And you need to know that the derivative, we see here we have a function, right? And then here's the derivative or the gradient. So you need to know that when you derive a constant, your answer is 0. I can show you why. Ne? So here we can introduce x to the power 0. So it's going to be 0 times 1, which will make this whole thing 0. So you need to know that the derivative of a constant is 0, right? Perfect. And then we're looking for the derivative when x is 1. So the derivative when x is 1 is the same as minus 3, 1 squared, where there was x, I put 1, plus 2. Then we can all see that our answer is going to be negative 1, right? Which means when we use the first principles, we must get negative 1 as our final answer, right? Perfect. And remember, ladies and gents, I said the question will be specific if they need the first principles. Otherwise, you're going to use the short method that I just showed you here, right? You only do first principle if they say do first principle. It's very tedious, right? Sharp. So we're going to write the formula down. K prime of x, or the derivative of k of x, is the same as the limit as h approaches 0 of k of x plus h minus k of x all over h, right? Sharp. Remember, before I start, guys, okay, but now let's do this. We're looking for k at 1, right? K prime 1, I mean. So every x value, we replace it with 1. So you have k1 plus h minus k1. all over h, right? So now I need to rewrite this. So I'm going to rewrite it twice. Now k, where I see x, I leave space, equals to, okay, let's go this side further because I need more space. So where I see x is, I'm just rewriting this, but where I see x is, I put brackets. Ne? So it's minus bracket cubed plus 2 bracket plus 1, right? And then this one, we're going to firstly look at f at 1 plus h. Ne? I'm firstly looking at this guy. So I'm going to have 1 plus h. Then I'm going to have 1 plus h. Ne? Okay, sharp. So we need to expand this. So it's 1 plus h, 1 plus h, because it's 3 of them, 1 plus h, right? Plus, here I can see I FOIL, I'm going to get 2 plus 2h plus 1. And then I can leave this bracket and deal with the last two first. So, but there'll still be a bracket there. So I can see it's going to be 1 plus 2h plus h squared. When you multiply these two brackets, you're going to end up with that. Ne? So here I have plus 2h plus 3. And then I'm going to have negative. 1 times this, it's 1. And then 1 times that is still that. 1 times that is basically that. And then h times 1 is h. Then h times that is plus 2h squared plus h cubed, right? Plus 2h plus 3. And then this gives us, we need to multiply the negative 1 in. So I have minus 1 minus 2h minus, remember, actually let's say 3h here, because this and that will give you like terms, which is 3h, and multiply by negative will give you minus 3h. This and that will be minus 3h squared, because it's going to be 3h squared. When you put the negative, it becomes minus. Then minus h cubed plus 2h plus 3, right? You can see that this and that gives you 2, right? This and that gives you minus h, right? And then gives you minus 3h squared minus h cubed, right? Sharp. And then that's it about this. Now we need k at 1. I'm sure you can see that we're just going to write everything like that, but now we'll be having ones there. So I'm looking for k at 1. It's negative 1 cubed plus 2, 1 plus 1. K at 1 will be basically 2. Ne? Perfect. So where I see k at 1, I can put 2. Where I see k1 plus h, I can put this guy. Okay, sharp. Let's go and simplify and see. Right. So let's see. So now I have this. Ne? I have the limit as h approaches 0. Remember I said where I see this, it's like seeing that. Ne? So I'm having 2 minus h minus 3h squared minus h cubed minus k at 1, we said is 2. So minus 2 all over h, right? Which is the limit as h approaches 0. You can see that this 2 will cancel with that 1, right? Then you can see that, okay, here we have a common factor of h. You take it out. Here you're left with minus 1. Here you're left with minus 3h. Here you're left with minus h squared all over h. Then this h will cancel with that. Now we no longer have a fraction. We can easily substitute 0, right? So when we substitute 0, the limit is disappearing. So we have minus 1, minus 3h is 0, minus 0 squared. which is -1, which is the same as when we used the rule. Then we know we are all right. And ladies and gents, please don't forget to share with family and friends and to hit the like button, the subscription button, and to leave comments on how you found this session. Thank you very much. Aluta continua.